Okay, so 7.7 is on operations on functions. So we know how to multiply, add, subtract, divide. We've done all those things with polynomials or with functions before. So we're going to learn one more thing. It's called composition. That's the thing you haven't seen yet. So let's start with the addition, subtraction, multiplication, and division. So addition, when you see that, you'll see it written two different ways. The way the book likes to write it is f plus g of x. But the way I usually write it is f of x plus g of x. Okay, subtraction, that's f minus g of x. So the f minus g is in parentheses. So that just means take the function f of x and subtract out g of x. Okay, multiplication, you'll see it written as f times g in parentheses of x. So that's just saying take f of x and multiply by g of x. Oops. Sometimes it takes a second. And then division, you might see f divided by g in parentheses of x. So all that means is f of x, take that function and divide by the second function. Okay, so like I said, we've done all this with polynomials before. So when you see f plus g of x, so for the first example, think of it as f of x plus g of x. So you're just taking the first function, 4x squared plus 3x minus 1. And you're adding it to the second function, so 6x plus 2. Okay, so look for your like terms. I have 3x and I have 6x. I have negative 1 and I have positive 2. So simplify, so I get 4x squared plus 9x plus 1. Okay, you guys try f minus g of x, so go ahead and try that one. The biggest mistake I see on these ones is they forget to subtract out the second function. So you need to subtract out the whole second function. So in other words, you need to distribute the negative. So change the signs of the second. So you'll have minus 6x minus 2. So when you combine, you get 4x squared minus 3x minus 3. So did you guys get that? Okay, good. All right, so let's compute f times g of 1. So what that's asking us to do is find f of 1 times g of 1. And you can do this two different ways. You can take your f function, so with x's, and you can multiply by the g function that has x's. So you have one big polynomial multiplied by another polynomial, so you get a huge polynomial. And then you can plug in 1. Okay, but we don't want to do that. We don't want to have to multiply huge polynomials if we don't have to. So the way I usually do it is I just say, well, what's f of 1? What's g of 1? And then I multiply them together. Okay, so we're going to find f of 1 first. So f of 1 is just look at your normal f function, so 4x squared. So 4 times 1 squared plus 3 times 1 minus 1. So when I do that, I get 1 squared is 1 times 4, so 4, plus 3 minus 1, so 7 minus 1 is 6. And then I find g of 1. So g of 1 is just plug it into the g function, so 6 times 1 plus 2, so we get 8. So all I'm asking is to find f of 1 and multiply it by g of 1, so it's just 6 times 8. So it's 48. Okay, I think that's a lot easier than multiplying polynomials. Okay, the next one, it says, given f of x equals 6x squared minus x minus 12 and g of x equals 2x minus 3, find each function. So this one says f times g of x. So there's no number there, it's just x. So that means you're going to deal with x's the whole time. So you're going to have two functions multiplied by each other. So my 6x squared minus x minus 12, and I'm going to multiply by that 2x minus 3, the g of x. So just f of x times g of x. Okay, and if you remember when we did this, you take the first term, you multiply it by everything in the second polynomial. So I have 6x squared times 2x is 12x cubed, and I have 6x squared times negative 3 is negative 18x squared. Okay, then I take the second term and I multiply it by everything in the second polynomial. So I have negative x times 2x is negative 2x squared. Negative x times negative 3 is plus 3x. Okay, then I take my last number and I multiply it by everything in the second polynomial. So I have negative 12 times 2x is negative 24x. And negative 12 times negative 3 is plus 36. Okay, the last step, you just combine your like terms. So 12x cubed, that's the only thing that has an x cubed. Then I have negative 18x squared and negative 2x squared, so that's negative 20x squared. I have positive 3x and negative 24x, so it's negative 21x. And then plus 36. Okay, that's your answer. Oops. Okay, the next one's f divided by g, so it's f of x divided by g of x. Okay, so I have 6x squared minus x minus 12, and then divided by 2x minus 3. Okay, so if we had just x minus 3 on the bottom, that would be a really quick synthetic division problem. You just put 3 in the backwards L, and you do your synthetic division. But we have 2x minus 3. So when we have that, in the past we've done long division. But on this one, you actually don't need to do either. You don't have to do synthetic or long division. So anybody have any ideas? Yeah, Ellie? Yeah. Do you guys see you can just factor at the top? So if you factor the top, hopefully there's a 2x minus 3 in it, because then you could just cancel it with what's on the bottom. So let's go ahead and write 2x minus 3. I don't know if that's how it factors. I do know, but you guys don't know yet. All right, so I'm going to multiply by something to get 6x squared. So 2x times something makes 6x squared. So you'd need a 3x there. And then I have a negative 3. I need to multiply by something to make the last term, to make the negative 12. So I need plus 4. Okay, and if you check your outer and your outer is 8x, and your inner terms make negative 9x. So 8x plus, or minus a 9x is negative x, right? So we're good. Okay, so that means we've factored the top and the bottom. So your answer is just 3x plus 4. So those factors have canceled. Okay, good so far? Go back here. Check this real quick. Oh, we're good. Okay. Composition of functions. Okay, so this is the new thing. This is the thing we haven't seen yet. So it says the composition of functions f and g, written as f, there's like a little tiny o, g, it's in parentheses, of x. So that's like a little open circle. It's real tiny. It's not an actual O, like the letter O. So everybody always says fog x. So f of g of x. You can go the other way, so g of f of x, and everybody always says gof x. All right, so what that is f parentheses g of x. It's f of g of x. It means the output of g of x is the input for f of x. Okay, so kind of confusing. Now let's do some examples. So on this one, I never liked that fog notation with the little o. So I like to write it with the parentheses. So I always rewrite as f of g of x with parentheses. Okay, and what you're going to do on these is work from the inside out. So I'm going to start in the middle. And I'm going to say, well, g of x, I was given. G of x is equal to x squared. So I'm going to replace that innermost piece with x squared, because that's what g of x was. Okay, so question. When I had f of 2, what do we do? How do we find f of 2? Yeah, you just plug it in, right? So you plug it into the f function. So in the f function, wherever you have an x, you replace it with that number 2. So this is the exact same concept. So this is where people get kind of lost. It's the same concept. You have an x plus 2, so that's going to be plugged in to wherever you had an x before in your f function. So instead of having x there, I'm going to have x squared. So I get 2 times x squared minus 3, which is just 2x squared minus 3. Does that make sense? Okay, do you guys want to try B? So go ahead and try B. See how you do.